This video will take you through the steps required to deliver the SolidWorks CAM first look demonstration that's in the What's New PowerPoint presentation. Typically you might want to show SolidWorks CAM in more detail during a breakout session or if you have a CAM booth set up at an event or show. First I'm going to start in the Ring Brothers hood hinge assembly, and the part I'm going to machine is the mounting bracket at the back, so I'll go ahead and open it up from the assembly. On the left hand side of the screen we have the SolidWorks CAM feature tree, and at the top we have the default machine tool that's going to be used. Opening that up, you'll be presented with a list of your available machine tools along with their parameters, and you can choose which machine you want to use. The Tool Crib tab displays all of the tools in your inventory. SolidWorks CAM can be configured to only assign tools to operations that you have available. This can eliminate the cost and risk of purchasing extra tools by mistake when you already have one that could be used. You can also choose which post-processor to use, and in this example I'll stay using the default FANUC controller. Next we'll take a look at how the shape of the stock workpiece is defined. In this example the workpiece has been defined by the bounding box of the part with a 2mm offset. In SolidWorks CAM the workpiece can also be defined by the shape of a model, useful when machining a casting, and it can also be defined from an STL file or a SolidWorks sketch. SolidWorks CAM can generate machining operations fast. Using extract machinable features, the automatic feature recognition technology analyses the geometry and assigns standard operations and strategies defined by your own manufacturing best practice. These include step over, cut depth, tool type and size. When finished, the operations generated are listed in the operations tree, and the toolpaths can then be calculated for either an individual or all the operations. Using SolidWorks CAM's powerful simulation capabilities, each toolpath can be previewed, enabling you to check for any potential collisions between the tool or tool holder and the part, and also compare the finished result against the original model. On our bracket you can see that the comparison results highlight that no operation has been automatically created to machine the top face down to its required depth. This is the area shown in dark blue. So another feature needs to be added to machine the top face. I'm going to do this manually using interactive feature recognition. Switching back to the CAM feature tree, I'll first choose to add a new 2.5 axis feature. The feature type is already set to open pocket, which is the one I want. So next I'll select the face on the model to machine. Selecting end condition presents the options that define the operation strategy and also view the default tool sizes that will be assigned. Next I'll set the depth. Choosing up to stock adds intelligence to the operation by ensuring that if the workpiece is made larger or smaller, this operation will always machine away the difference without me having to manually update the cutting depth. Finally, by selecting the island option, any areas to avoid can be automatically detected based on the model geometry. For this operation, the 3 mounting bosses are detected. When finished, the feature appears in the tree, and I can then go ahead and generate the operations for that feature, followed by the toolpaths. If in future, on similar parts I'm always going to want to machine an open pocket this way, this new feature and its operations can be saved back to the technology database, so that next time when I run automatic feature recognition it will also include the open pocket. This is how you build your machining best practice into SolidWorks CAM, teaching it as you program. Running a toolpath simulation with the comparison tool shows that all the operations required to machine the part to the correct size are now defined. SolidWorks CAM provides a number of ways in which you can further refine the machining operations. First I'll sort the running order of operations by tool size. You can also easily drag and drop individual operations to manually position them. For example, moving these 2 roughing operations above the contour milling operations. SolidWorks CAM provides you with a lot of flexibility for defining the order of machining operations and utilisation of tools. For example, multiple operations can be combined into a single one. I'll select the individual roughing operations for the internal pockets and combine them into one single program, using the same tool. Next I'll combine all of the contour milling and countersink operations that are using the same tools. The result is a far more efficient set of toolpaths with less tool changes. At any time you can edit an operation and change the parameters that control its toolpath. Here I'm going to edit the roughing operation for the outside shape of the bracket and change the type of toolpath from pocket out to volume mill. Volume mill creates a highly efficient toolpath combining a high spindle speed with a variable feed rate, allowing you to cut faster and deeper but under greatly reduced stress. It's easy to learn. The volume mill technology expert helps you assign the recommended feeds and speeds based on material. When finished, after closing the operation settings, the new toolpath is automatically generated. The resulting volume mill toolpath avoids sharp directional changes and will significantly extend tool life. Another great way to view and validate toolpaths in SolidWorks CAM is to step through each line while displaying the tool on the model. Looking at the volume mill toolpath, you can see that the feed rate varies for each movement of the tool to keep the tool pressure constant. And it doesn't matter whether you have a high-powered or an old low-end machine, you can use a volume mill toolpath with either. Being fully embedded in SolidWorks means that if I go and make a change to the design, for example changing the wall thickness of the pockets, that change in any others can be instantly propagated back to the machining operations and toolpaths in SolidWorks CAM. Just a simple rebuild is all that's required to apply the changes, making it quicker and easier to evaluate parts for manufacture much earlier in development without extra rework. So that's the first look demonstration of SolidWorks CAM that you can use at your launch events or when out visiting customers and prospects. And you can choose to show the demo in its entirety or just show specific parts depending on the scenario.